My name is Jody, and I am here to teach you about chest tubes today. So we're going to demonstrate the difference between a wet and a dry system, as well as show you a little bit more about the chest tubes, how they connect to suction, and then also share a little bit of lecture material for you as well. All of this information is in your lab supplement, so make sure to review that if you have any questions outside of this lecture. Otherwise, it's strongly suggested that you take notes while you are listening so that you can do well on the quiz and on the final exam. So, what is a chest tube? A chest tube, simply think of it as a drainage system. It is a tube, and this is an example of a tube. This is what the chest tube actually looks like, and it's inserted through the thorax, and it's used to prevent air and fluid from entering the pleural space. So think of the pleural space, so you have the lining around the inside of your chest cavity, and then you have the lining around the outside of your lungs. So you have the visceral pleura along the outside of your lungs, and the parietal pleura along the outside or the inside lining of your chest wall. The space between those two linings, so your chest wall and your lungs, that space in between is the pleural space. That's potential space. So every time you take a deep breath and breathe in, and your lungs move in and out, that space changes. What happens is if any air or fluid that doesn't belong in that space enters, it ruins the negative pressure that's inside that space, and your lungs can no longer be inflated. So the chest tube is inserted into that pleural space to remove air and fluid so that negative pressure can be restored. So you'll see this commonly after a trauma or a surgery, and this would treat a pneumothorax or a hemothorax. So a pneumothorax can be spontaneous. You could have this as a result of a chronic disease, or if you had a spontaneous bleb. It could be internal trauma, so think if you had a rib fracture and the rib on the inside punctured the lung, but there was no opening to the outside of the chest wall, that would be called a closed pneumothorax. You could have an open pneumothorax if there was like a bullet wound or a blunt force or a stab that penetrated through the chest wall. So open, closed, or spontaneous. Or you could have a chest tube after any surgery that entered the chest cavity. So we would want to promote drainage outside of that space as well. So this is all about negative pressure, and we want to keep that negative pressure intact in the lungs. There's also something called a tension pneumothorax. So that's when air accumulates in that pleural space more rapidly than it can be evacuated. And you'll remember, and you're learning from patho and adult health, that a tension pneumothorax is bad, bad, bad. That is a life-threatening emergency. That's when all the pressure builds up and collapses the lung, and you'll see a medial sternal shift that will cause decreased cardiac output because there's increased pressure on the heart, which would lead to cardiac arrest. So that's something to be aware of as well. So looking at the chest tube drainage system, to make this as easy as possible for you, there's 3 chambers. And there's a wet versus dry, but we'll show you that in a little bit. So this A chamber is the suction control chamber. This is what controls the amount of suction being applied within the chamber from the patient. This B chamber here is the water seal chamber. This is what restores and keeps the negative pressure and makes a closed system for the patient. This window here at the bottom of the water seal chamber, that is the air leak monitor. And then the rest of it, or over half of it, that's just the drainage collection chamber. Okay? Now the big difference between a wet and a dry system is the suction. So on a wet system, You'll see here you have 20, 15, 10, 5, and you'll notice that there's fluid in here. This system, in order to set it up and to follow the ordered suction, you have to take sterile water and you would take off this cap and you would fill up with a funnel in here. And you would fill up with a funnel to the ordered amount of suction. You're going to find this information in your provider order. So it would say chest tube to 15 milligrams of suction, for example. So this one's filled to 15. Over time, this is going to bubble, which I'll show you that in a little bit and how to adjust that. This will bubble, and over time, this water level may change. It's kind of like if you went to go boil a pot of water on the stove. If you let it boil for too long, some of the water is going to evaporate. So you have to keep your eye on making sure that this is the water levels at your ordered level of suction. If the suction level, let's say the doctor changed it to 20, you could easily fill it up to 20. If they decrease the suction, you would have to get a whole new system. These, think of, they're hard plastic, they're disposable, and that's okay. Okay? In a dry system, the suction's right here on this monitor, so you simply just turn the dial to your ordered suction. That one's pretty easy. So a wet one, you have to put the sterile water at the ordered suction amount. The dry one, you just turn the dial. Now, as far as adjusting the suction, you'll notice on the dry system, there's a suction control window here. And when you have the right amount of suction, a red float will kind of come up and show in that window. So I've already turned on the suction and have it set. So watch the window. You see that red float in there? So that means I have the suction turned on enough to apply the correct amount of ordered suction for this patient. So that's all you're adjusting for that one. For the wet system, this one you have to play with a little more. So we're going to apply the suction, and you always have suction turned to regular for this. And what you're going to be watching for is bubbling in the suction control chamber. So right now I have it off. So I'm going to turn it on. Okay. Now, we don't want this bubbling so rapidly that it sounds like a fish tank in the patient's room. This is way too high. It's bubbling like crazy. It's going to evaporate. We want a slow, intermittent, gentle bubbling. So I'm simply just turning down the suction. And that's still a little too fast. So normally, and you know in the lab the suctions aren't totally calibrated, there's this little turn dial here. This is where you can kind of fine tune the suction. I don't know, Katie, if I can switch that. But do you see how this one kind of turns on here? So if you had trouble adjusting it on the wall, like right now the suction in here says 0, they're not calibrated right in here, you would turn the suction on and then you could adjust this to kind of have a finer control. So you would want this even less. Let's see if I can get it. There we go. Do you see how it's just intermittent, gentle bubbling? That's what we're shooting for. Okay? So that's suction. Next we'll go to the water seal chamber. So the water seal chamber is set up for you. Per the manufacturer, you will have to fill this to a certain amount, depending again on the provider order. And in here, the part of this is controlling or restoring that negative pressure in the lungs. So if you have a hole in, or anything's disrupting your pleural space, air is able to get out and come back in. That doesn't create a vacuum or that negative pressure, so your lung will collapse. So in order to restore that, we want to let air get out, but not back in. And so that's what this does. Think of if you put a straw in a glass of water and you were blowing bubbles into the straw. Air can get in to the glass of water, which would be this, but you can't breathe air back out through a straw. So in turn, that is exactly what this is doing. It's closing that hole, letting all the air and fluid get out that shouldn't be in there, and not letting any new air in, so that the lungs can re-inflate and they're no longer collapsed. Okay? So that's what this is doing. It's kind of like your straw in the glass of water. And then also this is where you would see an air leak. So you'll see on the air leak monitor, it's calibrated 1 through 5. So if you had bubbling that went to here, it would be a +1 or a +2 or a +3. And the big thing with the air leak is you're just making sure that it didn't get any bigger. So it's very common for someone to come out after surgery or right after this is placed for them to have an air leak. An air leak would be any air that's upsetting that negative pressure. So it could be on the patient side, coming out from around the tube around the patient. It could be somewhere within this system. This is hard plastic, so if this falls over, it could crack. It could be on any one of these connections to the patient. Just like with your NG tube where this is connected to the patient, we just use a tree. So, you know, sometimes air can leak around here. So a lot of times, so this would be my chest tube going to the patient, and this would be going to the drainage chamber. We would have this connected, but we would also put zip ties around here or tape this up really good so there would be no air leak. It would also prevent it from getting disconnected. So that would be really important. So it's not so uncommon to see an air leak. You're just watching to make sure that it doesn't get any bigger. If you have a bigger air leak, then we need to troubleshoot. In order to troubleshoot an air leak, you're going to take a Kelly clamp or you can just kink it, and you're going to watch for the bubbling to stop. So if I kinked my tubing, so let's say there's an air leak in here, and I kink my tubing and the bubbling stops, that means I stopped the leak. That means that there is an air leak somewhere above where I kinked it. So in this case, this would be like the chest tube inside the patient. There's a leak coming from the insertion site around the skin of where the chest tube's going into the patient, or at the connection where the chest tube is attached to the drainage chamber. If it was still bubbling in here, that means it's somewhere below, so that would mean it's somewhere with the connection with the chamber, or there might be a crack in here or something. So in that case, I would just get a whole new collection chamber and restart that. Okay? That's all the air leak is. Don't be too freaked out by that. You're just monitoring. Okay? Same for in this one, the air leak monitor would be here. And then the final one is the, I'll pause this so it's quieter. The final one is the drainage chamber. So you'll notice on this one there's no drainage in there, it's empty. On this one they have some drainage. You'll notice that it fills this way, so the numbers are smaller here, and then it would overflow and go down here, and then it would fill back up and fill up this way. The color consistency quantity is what you're always monitoring with drainage. Since this is filling constantly, you would want to be always monitoring the drainage coming immediately outside of the patient in the tubing versus the color in here, because if it was darker red mixed with lighter red, that would be changing. It's kind of like mixing Kool-Aid. So make sure you're monitoring that here in the tubing. Here you would measure, we usually take a Sharpie and mark the time with our initials. Here. This one you can see how there's some in each chamber. This means that it got tipped over somehow, which isn't good. So if you ever notice that it's not filling properly and it got tipped, that would be another scenario where we would get a new chamber as well. Because that could mean that it would be cracked, and we don't want that. You'll also notice there's a handle on these. There's little clips here. This one only has one for some reason. It broke off. Normally there's 2 little clips, and you can hang this on like a walker or something if they were going for a walk. If they needed suction, you could get portable suction. And then there's also a stand at the bottom that this collapses and goes up if you needed to use that as well. You just always want to make sure this support's in place when you put it to the floor, and sometimes it'll even get taped to the floor. So that's the chamber in a nutshell, as well as how you check for an air leak. Don't be intimidated by these. I think it's really easy. The concept of chest tubes, and it's kind of overwhelming. If you just break it down by the 3 chambers and what they do, and think of it just as a collection chamber, you're going to be just fine. Just make sure you really understand the negative pressure situation and the need for a chest tube, and I think the rest will kind of fall into place for you. Other things to be aware of for chest tubes are other things to have in the room. You always want to have a container of sterile water in the room. Obviously, if you need to readjust the suction. Also for troubleshooting, if the chest tube ever came out or disconnected, so let's say this is in the patient's pleural space and this is coming out of the patient, you walk in the room and this is open like this and it got disconnected. Now air is coming out and going in, so that's going to increase the pressure inside the cavity. So in order to remedy that and to create this suction control chamber, you would simply open up sterile water and you would stick this in like that, and you would call a rapid and you would get a new, get this reconnected. If you just found this laying in the bed, you could easily alcohol the end of this off and quick reconnect it as well. Just know that this sterile water is going to restore your negative pressure, and that is going to be this chamber right here. Okay? Other troubleshooting things, if this chest tube totally falls out, that means that they have an open wound, that air is getting out and coming back in. That would be an emergency as well, because again, that will increase the negative pressure, causing more pressure to be put inside the cavity, which could result in that tension pneumothorax, which would be an emergency. If that happens, then you want to create a 3-way valve with a dressing. So you would take a 4x4, which I didn't grab one, the paper of the 4x4, you know how you open up a 4x4, you rip it open and you have 2 pieces of sterile paper. You're going to put the sterile side, or the side that was to the gauze, down over the wound, and you're going to tape 3 sides so that one side's open. So when they take a breath in, the paper is going to shut on that wound, and when they breathe out, the paper is going to open up. So that's going to let air go out, but prevent air from going in. So you're always going to want 4x4s, and you're always going to want sterile water, and you're always going to want a clamp, okay? Really important as well. Typically, on the patient side, where this is inserted, this is always a sterile dressing change. Typically, the provider will order a Vaseline gauze, which looks like this. It's a gauze bathed in Vaseline, so it's really moist and sticky, and so this would be a sterile dressing change. This is an occlusive dressing, so this will help prevent air leaks because it sticks to that site, and you kind of wrap it around, and then you might put more 4x4s and then tape over with this kind of microfoam, which you can kind of see. It's flexible, and sticky, and that will go over the whole site as well. Other things to note when you're assessing, you're always going to start from the patient and work your way down. So you're assessing the site, you're assessing for crepitus or subcutaneous emphysema to make sure there's not an air leak around the site. You're assessing the dressing and the insertion site. You're assessing all of your connections. You're going to work your way down the tubing to make sure these connections are good. You're going to check for air leaks. You're going to check to make sure that the suction is where it needs to be. And then you're going to assess the drainage, both in the chamber and then for the amount and in the tube for color and consistency. Respiratory assessment is important. The skin assessment is important. And then pain. For these patients, think every time you take a breath, this tube is going to be between your ribs, and in between your ribs are your intercostal muscles. So every time you take a breath, this tube moves in and out a little bit. And so they're always going to be uncomfortable when you have a chest tube in. So pain management is super important at every patient interaction as well. And then, as you know, documentation, all of those things we would be documenting. We should have our eyeballs on this at least every 2 hours to make sure that everything is as it should be. So while there is a lot to check with this patient, if you kind of work your way from the patient down and then back up and just go through each chamber, you should be just fine. And then just remembering those troubleshooting pieces as well. So don't make it complicated. Review ATI, but that is chest tubes in a nutshell. That's it.